So hi everyone, I am Miss Maple. So in this video today, right, I'm going to show you how to remember the cation and the anion list. Alright, because I asked some of you to remember this and you tell me, oh Miss Maple, this is a bit hard to remember. Actually, it's very easy. So first thing first, organize our mind. Since they are both cation and anion, we can focus on either of the group first. We focus on the cation first, okay? So just focus on anion. Now, when you look at the cation, you will realize that there are actually three parts. Okay, the first part is where the oxidation number. Okay, let me just write this down. Where the oxidation number is just the positive one. Okay, oxidation number is positive one. So oxidation number is the number of the top right side. Okay, so it could be either positively charged or negatively charged. If the oxidation number is positive charge, it is the positive ion or known as the K ion. If the number, okay, is negative, vice versa, it is the negative ion, also known as the anion. Okay, right? So what does the 2 plus on the right side mean? Other than showing this is the oxidation number, it also means that the 2 plus is giving away or donating away 2 electrons. Okay, if this is if this is 3 plus, right? For example, if this is Al3 positive, right? It shows that the aluminum ion has given away 3 electrons because they are generous. They are having the positive side. Okay. On the other hand, right, chlorine. Okay, as you can see here, chlorine. As you can see here, chlorine here, you see it has negative, right? Oxygen ion or oxide, it has 2 negative. Okay, 2 negative, meaning
2 negative means they receive. Receive how many? It receive 2 electrons. And chlorine, because it is only negative 1, it receive 1 electron. So that's the main idea of the positive and the positive, negative, the charge, as well as the number. Alright, so now let us go back to the table here. Okay, now that you know the idea, positive ones means giving away 1 electron. So for the first group, right, you will...
And what do you realize in the similarity between hydrogen, sodium, potassium, and lithium? Yeah, okay. So as you can see, these 4 elements are from group 1. Therefore, they have the oxidation number of positive 1. Group 1, they have 1 valence electron at the outermost shell. So all their shell, they have only 1 valence electron. So in order to make them stable, they prefer to give away. Okay, they want to give away so that they can achieve the stable state. So they would like to give away. So likewise, you see barium, calcium, magnesium. Calcium, magnesium, yes. 3 of them, they belongs to group 2 because again, it belongs to group 2. So it has the oxidation number of positive 2. They give away or they donate away 2 electrons. Alright, so for the rest of the other elements like copper, zinc, lead, iron, these are actually the transition element. Transition elements means they are usually located at the middle of the periodic table. You see, zinc, iron, and then zinc, iron, copper, and lead. So you see they are somewhere around located at the middle part. They are considered transition element of the periodic table. That is why they have more than one oxidation state. They have more than one. So you might ask, oh, this has more than one, right? But why is this showing only positive 2? Again, because for IGCSE level, for our level, there is actually another one which is Cu plus, copper positive one. But again, we don't usually use it. This is not everything here, but this is some of the very common ones that it is best that the student can know. Okay, so for Cu plus, it is actually present, but we don't really use that often, so this is not very common. So instead, when we talk about copper, right, the one that came out in your mind is the Cu2 plus, Cu2 plus, so you can remember it. Zinc, it is also very common in 2 plus. Lead, yes. For iron, right, iron is a little bit special, okay? Iron, again, like what I said earlier, iron is a transition element. They have more than one. I repeat, transition element has more than one transition element has more than one oxidation number, and hence, because it has more than one, for iron, for the positive 2 and positive 3, right, they are equally common. They are equally common. That's why we have to remember the two of them. All right. And also in wording, right, because it is very common, so when you write them in word, you have to include the bracket of iron 2 and iron 3. All right. And last but not least, group 3. So aluminium, as you can see, group 3 aluminium. Okay. So this is it for the cation list, anion list. As you can see here for anion list, right, chlorine, fluorine, chlorine, bromide, fluoride, iodide, right? What is the similarity of these 4 elements? Okay, now let's look at the periodic table. Chloride, bromide, fluoride, and iodide. Chloride, bromide, fluoride. Yes, they belongs to the group 7. They belongs to the group 7. And what does that mean? So it means that they have, let's say, this is their outermost shell. They have 1, 3, 4, 5, 6, and 7 valence electrons. So in order for them to be more stable, right? In order for them to be more stable, they prefer to receive 1 electron. They want to receive 1 electron. They want to receive 1 electron in order for them to be stable. So in order for them to be stable, they like to receive only electron. Okay, they like to receive only 1 electron in order for them to be stable. So this is because they are group 7. So in this way, you can remember, if they are group 7, they will have the charge of -1. All right. Now, just remember it. OH minus is plus. Okay, is ion, and react with OH minus, they will form together a water molecule. OH minus, just remember it. For nitrate ion, yes, also have to remember it. Right. If you notice, oxide, it belongs to group number 6. Group number 6. Again, it has 6 valence electrons, so they need to have 2 more electrons. They want to receive 2 more electrons. So that's why they show the charge of -2. All right. So having to say that if oxide ion is 2 negative, sulfur is also 2 negative. Here. Yes, it shows that the sulfur ion, as you can see here, oxygen belongs to group 6. It shows that the oxygen and sulfur, they have the same charge, which are -2. So this is also because they belongs to group number 6. And then for sulfate, you see it ends with the letter ATE, sulfate ion, means it has oxygen. Whatever compound, right, especially the anion, if they ends with the letter ATE, it shows that it has oxygen. Nitrate ion, NO3 minus. Sulfate ion, SO4 2 minus. Carbonate, CO3 2 minus. Okay, so for sulfate and carbonate, right, these are considered complex ion, but actually, right, you will come across sulfate ion, carbonate ion, these two quite frequently in chemistry. So the more you see, right, if you remember it, take effort to remember it, right, it is not that hard to just remember, because why? They are very, very common. You will come across it very frequently in chemistry. So I hope after this explanation, you will be able to remember it. So to recap it again very quickly, chloride ion, bromide ion, fluoride ion, iodine, group 7. They belongs to group 7. So they have the charge of -1. They need to receive, okay? They want to receive one more electrons in order for them to be stable. For oxide ion, sulfur ion, O and S, oxygen, sulfur, they belongs to group 6, so 2 negative. For the rest of the other anion, complex ions, yes, you can just remember it first. All right, that is it for today. Thank you, class.